And then when you're talking about discrete or data in general, you need to know some more terms. So for example, there you always have a minimum, which is the lowest data value. So in this data set it would be 38. You have the maximum, which is the highest data value, which in this set would be 45. And then you also have the mean, which is essentially the statistical word for the average, which you find by taking the sum of all the data and dividing it with the number of data points. So here you would take the sum of 38, 39, 40, 42, 42, 45 and divide it by 7 because there's 7 data sets, which is then equal to 40.57. So it means that the mean of this data set will be 40.57. Now next you have the median, which is essentially the middle number, and you find it by taking the number of different values in your set plus 1 divided by 2. So for example, in this data set we have 7 different numbers, so you take 7 plus 1 divided by 2 equals 4, and that means that the fourth number in this data set will then be the median. One important point is that if you have something like this where the median number equals to something which is not a whole number, something that is not a natural number, you have to take the average between the two middle numbers. So in this case with 4.5, it would mean that you would have to take the average between the fourth number and the fifth number. And yeah, this is not for this data set here. Next we have the lower quartile and the upper quartile. So for this we're going to take another data set, which is here, and one thing you'll notice is that we have a number 51 which is pretty far away from the rest of the data set. This here is what we would call an outlier, and if we were to include this in our analysis, it would drastically change all the different values. For like for example, the mean will be way higher, all the lower half and the upper half and all that, everything would be much higher than it should be. So because of that, usually when you have an outlier like this, you just don't count it and just mention that it's there, and it would tilt the data set in one direction, which would make it a bit more inaccurate if you were to include it. So with this data set, we can see that the median, which is again the middle number, is 19 plus 1 divided by 2, meaning that the median is the 10th number. And if we count here, the 10th number is number 43 here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 43. Then the next term that you can use is the range, which is essentially the maximum subtracted by the minimum. So in this case, our maximum is 47 because we're not counting the outlier, minus 38 equals to 9, so the range is equal to 9. And then we also have the interquartile range, which is the upper quartile subtracted by the lower quartile, which is 46 minus 40 in this case, which equals to 6. Next, we can take the box and whisker plot. The box and whisker plot looks like this, and what you call out here in the ends, those are the whiskers, and this here in the middle is obviously the box. And the way it works is that the whiskers represent the maximum and minimum. So here the minimum is 38 and the maximum is 47, and out here you can see our outlier, which is 51. Then you can take a look at the box. This part of the box here represents the lower quartile, which is at 40, as you can see here, just like that. This line here represents the median of the entire set, which is 43, as we found out before, and this line here represents the upper quartile, which is 46, as we found out here. So this is going to be about statistics. So first, when talking about statistics, we need to know some terms. So when you have a data set, as we can see here, this would be a data set of a small sample of shoe sizes in a class, for example. Using discrete data, it means that you have all the specific data values in a list, like something like this. But you can also have a continuous data set, which is with intervals, as shown here, where 38 to under 40 in shoe size is 3, because in continuous data sets, you essentially take intervals and then show what the frequency of that interval is, rather than just showing all the different numbers. And which means that continuous data is generally better for quantitative analysis, while discrete data is better for qualitative analysis. So next we have cumulative frequency. Uh, well, essentially this is where you count the frequency of your results in a cumulative way instead of just one at a time. So here we have another data set. This is again shoe sizes in some class, for example. So here we have the different observed shoe sizes, or the different shoe sizes it could be. Here we have the frequency of each of those shoe sizes, and in total we have 18 because there's 18 students in this class. And the way you will count it is essentially you take the first frequency, that's 1, and then there's 0 of this frequency, or 0 of this observation, so there's nothing to add. You see there's one observation of this, so you add 1 to the result before. There's 0 again, so you add nothing. Here there's 2 of this observation, so you add 2 to the number before. Here there's 4 of that observation, so you add 4 to the number from before. Here there's 1 of this observation, so you add 1 to the number before. And essentially you keep on adding the current frequency to the total amount you've counted so far. So in total, you should end up with this number down here, which is the total of observed frequencies, should be the same number down here as the end of the cumulative frequency. So what you can do with this is you can make a graph like this, where you start out here with this observation and this a frequency of 1, for example. It doesn't have to be 1 necessarily, but it can be. And then you essentially show it as it progresses what the cumulative frequency is for each observation. So you go up and up, up and up, up. And this graph will always go upwards in this way. And yeah, one thing you can do again here, you can take the lower quartile, which has been calculated to be 38, the median of which has been calculated to be 39.5, and the upper quartile, which has been calculated to be 42. And what you can do is you can draw them onto your graph here. So this here would be the lower quartile, this here would be the median, and this here would be the upper quartile. And this can help you see the way all the values are spread out on the graph or in our sample. One thing that it is also important to mention is this term called the mode. And the mode is essentially the number which is, or the data which is the most frequent, which in this case, as you can see here, looking at the frequency of each observation, 38 has been observed 4 times, meaning that the mode of this data set will be 38 because 38 is the most common of all of these results.